We will begin our construction of the wing with the right wing spar. Now it's important to get the left versus the right spar identified, and I've labeled it right on the face of the spar. Now you can tell the front from the back of the spar by noticing that the spar fitting, this piece right here, is on the front. So this is the front of the spar, and this is the right or passenger spar. We will demonstrate the construction of the right wing, and then you can build the left wing on your own. We chose the right wing because this is the one that is depicted in the plans, so it should make our job a little bit easier. I have labeled a set of pre-drilled holes that appears on the spar with a number, in this example 280. That is simply the distance from the edge measured right here, and this part goes towards the fuselage. And these are called stations on the plan, so this is station 280, which is the line that is 280 millimeters from this edge. And it is at these locations that we will place ribs or L angles, etc. You will notice we have one for 480, and I put an L there because an L angle will go there. And then a location at 880, 1160, which is going to be another L, and so forth. So by identifying these pre-drilled holes and labeling them on the spar, it will make it much easier, and it'll be less of a tendency to make a mistake and place a part in the wrong spot. We will begin by creating the 3 L stiffeners that go on the face of the spar web. Now we're going to cut this from our standard L stock, 206 millimeters. We need 3 of these for each spar. And on the back we want to draw a line down the center. It's going to be our rivet line. And then, looking at the plans, we're going to place them at 3 locations. The first is at station 480. And there's, of course, a set of pre-drilled holes through the spar web. And we're going to place the L angle so that we can see the line we drew through these pre-drilled holes, and place it right here. The edge of the L angle faces towards the tip of the wing, and we'll clamp this in place and make sure we can see the line through the pre-drilled holes. We can also throw our square on here just to make sure that this is square with the spar, and then go ahead and drill, and we want these to be size 30 holes through here. And now we have 2 more to do. There's one more L to be located at the 1160 station. And then another to be located at 2760, all the way down near the tip. Double check your plans for placement, but they will also be attached in a similar manner. When it comes time to riveting, I should point out now that the rivets that are going to be in the spar cap, the extrusion up here at the top and the bottom, those rivets should have their heads on this side, on the front side of the spar, just like these guys are. But all of the other rivets in the web of the spar should have their heads on the back side. Our next step is to take the nose ribs, 7V11. Now, there should be 6 of these, and we want 6 for the right side, the right wing, the passenger wing. The easiest way to tell that is the flange needs to be pointing or bent towards the tip of the wing. So as it sits flat, the flange should point towards the tip of the wing. Now these are going to be mounted on the front face of the web of the spar, located at the stations, and these stations are listed, there's 6 of them, on your plans on page 7V3. The first thing to do is on the back of each of the flanges is to draw a center line. This will be our rivet line and will help us to accurately position the flange against the face of the spar. I will demonstrate installing one of them. In fact, I'll do it at station 280, which is the very first station towards the fuselage end of the spar. And then you can go ahead and install the other 5. So there'll be a total of 6 of these. Station 280 is located, of course, 280 millimeters from the edge over here. And there's a set of pre-drilled holes. And we're going to take our first nose rib and position it right along those set of holes. Now the goal is to position this carefully up and down so that it is nice and even with the top of the spar and the bottom of the spar. We have a little technique that will help us keep it nice and even while we drill. And of course, the goal in all of this is to make sure we can see the line we drew through the pre-drilled holes in the back of the spar. It's just a scrap piece of aluminum extrusion, and what I'm going to do is mount this, clamp it down here. I've laid the spar down flat, this is the back, and I'm taking my extrusion and I'm going to line it up with the holes, and then I'm going to take a spring-loaded clamp and simply clamp the extrusion in place. I can now turn it back over and simply place it on top of the extrusion. Now what this is doing for me is making sure that the bottom and the top is lined up perfectly with the spars. And so with a clamp at the top, I'm holding the nose rib tight against the spar. The bottom extrusion is holding it even with the edge of the spar. In fact, I can put a clamp on down there to make it nice and secure. And now I am able to drill from the back, knowing that the nose rib is perfectly aligned. I confirm that I can see the line through all of the pre-drilled holes, and I can adjust if necessary to do that. I can go ahead now and drill all 6 holes through the spar and into the nose rib. And before drilling each rib, it's nice to confirm that they are square to the spar. Here we have all 6 nose ribs installed and clecoed in place. Before removing the nose ribs, it is best to label each one either by number or with their station number so that they can go back to exactly their same location. Same with your L angles. Because we want to now remove the nose ribs as we are now prepared to install the rear ribs. We have 6 rear ribs. Make sure you find the ones for the right wing. Again, they can be identified by putting the flat side down, curved side will be on the top, and the upper flange will bend towards and point towards the tip of the wing. To help determine the top versus the bottom of the rib, note that the bottom flange is nearly perpendicular with the side flange, whereas the top flange quickly curves down in relation to the side flange. Now, all 6 rear ribs are the same except for one of them. So actually, let me say this differently. 5 are the same and 1 is different. The one that's different simply only has 2 lightning holes. The other 5 have 3 lightning holes. The one special one, 7V12K, with the 2 lightning holes, is going to be positioned at station 280. The rest of the 5 will be positioned at the very same stations that your front nose ribs were positioned at. All of these rear ribs will be attached to the rear of the spar. And so our first step is to draw a rivet line down the center of each flange, so that when we position these behind the holes that we have already drilled out on the flange, we can see this line. So I have a piece of extrusion clamped on the bottom and the top spar cap, and then the rib can fit in between them, and then I will clamp the rib to the extrusion. Can then turn this around and then drill through the web into the rib, as long as I see the line through the pre-drilled holes. And in this case, there will only be 4 holes to drill, as the holes at either end of the spar cap do not go into the flange of the rear rib. And I will repeat this for all 6 rear ribs. We also want to make sure before drilling that using our square, we have the rib quite perpendicular to the spar. Now we've connected the front and rear ribs together with clecos. And notice that the rib towards the fuselage has only 3 lightning holes. Now we're going to install the tip rib, 7V33. Now we want to make sure we have the tip rib for the right wing, the passenger side. Notice that the point is on the top as opposed to the bottom, and the flange is to face forward. And this will go at the end of the spar of our right wing, and it will sit on the front of the spar with the flange facing forward. Now, in preparation for installing, we want to draw a line 10 millimeters in from the edge. This is going to overlap the spar by 20 millimeters. So in order to see this line 10 millimeters in through the pre-drilled holes in the spar, which are right here, we want to hold this up until we can see the line through the holes. And what I'm going to do is go ahead and drill the bottom hole first and cleco it, and then make sure I have this nice and straight so that it is in line with the spar. And then go ahead and drill the rest of the holes. Total of 4 holes in the web to hold this on. And check your plans if there's any question as to how that is to fit. Now we're at the fuselage end of the wing, and here's our mounting tab. What we want to install now is 7V41 little nose rib. And the way to set this up is to use a piece of extrusion underneath the edge of the spar spar ends right here. So I'm going to clamp this on. And then we can take our nose rib and simply set it on top of the extrusion, and it's going to go even with the edge of the spar here. And if you look behind the spar, you'll see a couple of holes, and we're simply going to drill into them and into the flange of the spar and hook it up with clecos. Once we have the front nose drilled, we can remove that and work on 7V4 to the rear rib, and we'll use that same extrusion to line it up and drill through the 3 holes in the front. Then we can clamp the nose rib back in place. All 3 of the holes need to be drilled out to A5, including the 2 in this piece also. Now we have one more procedure to cover. We need to create a small piece of metal. This does not have a part number. This is just a scrap piece of 25 thousandths. And it's going to bridge the front and rear rib just like that. So simply cut out a piece of scrap aluminum, 4 holes so that 2 go in the front and 2 go into the rear. And these will ultimately be A5, and attach it right here. And the last procedure in this area is this flange right here needs to be bent down because there's a gap in here, and that's not good. So I'm going to remove this and use a pliers and carefully bend this gently down so that it's touching the top of the nose rib flange and makes a smooth transition rather than having this gap right in there. That's 7V4-5. Now there will be 4 of these for each wing. 8 of them are similar, so you can grab any 4 you want. Our first step is to mark and drill 2 holes. Now these are on your plans. The location of the holes are on your plans, that is. I believe they're 8 millimeters from the edge and then 55 millimeters apart. And your plans will give you the distance for one of these holes from the edge. You want to drill pilot holes for those 2 locations, and then once you have those drilled accurately, use this as a template to drill the rest of them so that all the holes are made in exactly the same location for all 4 of them. Next, we're going to prepare the slat template. Now, this is a gizmo that you're going to make up for the purpose of locating the slat support brackets accurately on your ribs. Now, this is in your plans. Basically, all it is a piece of aluminum. I believe this is 1/8 inch thick, or actually a 63 thousandths thick, but the thickness is not important. It just has to be nice and rigid. And then I've taken 2 pieces of extrusion and at 90 degrees mounted them with a set of rivets. So I've sandwiched this plate in between the 2 extrusions. Now, the size of this plate is in your plans, and what's really important is locating 2 holes. Now, this hole is listed in the plan, so that's easy to find and drill a pilot hole. The second hole, they don't give you its exact location. They do say, though, to draw a vertical line 35 millimeters from the edge. And then the hole will be somewhere along this line. The way you find that second hole is to take one of the slat support brackets that you previously made, and attach the first hole that you drilled to the lower hole in the support bracket. And I'm just going to cleco that in place right now. And then you're going to rotate the bracket until you see the line through the hole. And when you see the line through the hole, you go ahead and use your drill and drill through the hole, through the line, and that will provide you with the exact location of the second hole. The reason we're doing that is that this template is going to be able to hold our brackets exactly in position when we attach them to our nose ribs. The slat support brackets are not going to be attached to every nose rib, just number 1, 3, 4, and 6. I have numbered my nose ribs so that they correspond to this numbering system. The very first nose rib closest to the fuselage on the right wing is 1. The second one I'll number 2, the third one 3, all the way to the last one, number 6, at the far tip. The slat support brackets are going to be attached to number 1, 3, 4, and 6. So I'm going to remove those 4 nose ribs and place them on our bench. Now I'm going to take my positioning template, one of the support brackets, and cleco them to the 2 holes of the support of the positioning bracket. The slat bracket now is firmly affixed to the positioning template. I can now take one of my ribs. I'm going to start with nose rib number 1 and place it on top of the positioning template. So the bottom is tight to the extrusion, and I'm going to slide it forward all the way until it stops. In other words, until the nose touches the edge of the bracket. And I'm going to turn this around so you can see. So notice that, and I can use a clamp to keep this nice and tight. Tight to the bottom, and the nose just touching the edge. I will clamp the nose rib to the positioning bracket, and what that will do is show the exact location of where the slat bracket will be located on the nose rib. What I'm going to do is use a marker and mark the edge of the bracket. Now, when I remove my clamp, clamped it over here, I'm left with an area where we need to prepare another component that gets riveted on here. As part of our slat bracket construction, we need to fabricate a part out of an L. Now this is a standard L, 120 millimeters in length. We're going to make 4 of these, 1 for each bracket on this wing. We want to place it on our bench and draw a line. Now this is the outside corner here. inside corner, outside corner. I want to draw a line about 4 millimeters up from the bend on the back side here. And along this line, we want to mark locations where we're going to drill a hole. This is in your plans, but basically the first one is 20 millimeters from the edge, then 16, then 19, 19, 16, and that should leave 30 millimeters from this edge. So at those 5 locations along this line, we are going to drill a size 20 hole at each of those locations. When we're done, it should look something like this. See those holes? So the holes are almost to the very bottom of the bend. Remember, that's the outside of the angle. What we're going to do now is trim using our snippers from the edge to the sides of each of the holes, creating slots. And when we're done, it will look something like this. So notice I've simply taken my snips and cut down to each of the holes. I made them a little bit wider. They look like a little bit like these, but the important thing is to include the hole at the bottom. What that's going to allow us to do is bend this. And when we're done bending it, it will look something like this. Basically have bent this into a curve. Now, before you go bending it, let's take a look at what we're trying to accomplish with this bend L. Here's one of our wing nose ribs. On the edge here, it's not very wide, it's pretty narrow. And the skin of our wing has to go around this curve. And because there's not much meat there for the skin to be attached to, or in other words, if this were the skin of the wing, it's going to go something like this around each rib. What we want to do is use this bent piece an extra surface area for the skin to go across on. So we want to form or bend this L that we just cut up so that it matches the contour of the nose. Now, if you look closely, I've also drawn locations of where we're going to drill holes. Basically, we're going to have a hole in each of these little fingers. So a total of 6 holes. I haven't drilled these yet, I've just marked them. But the first and the last hole must fit within the area that our slat is going to be located on. That's why we located the slat bracket on there. So while forming this curve and bending it to match the contour, we want to make sure that this hole and the last hole falls well within our lines here, because that will end up getting drilled through our slat bracket. Now, when coming up with the contour, it can be helpful to take a scrap piece of metal and bend it around so that you can bend this appropriately. You don't want it sticking out too far, you don't want it sticking too far back, because, as we mentioned, the skin of the wing wants to sit nice and flat across here. This L that you bent up will become the surface that we can rivet our skin into in lieu of the thin or narrow area available on the tip of the rib. So once I get this located properly, I'm going to first go ahead and drill these holes, place it on here and make sure the holes are within our boundaries, make sure that the bend fits the contour of the tip using the skin to confirm, and then go ahead and drill and cleco. I'm going to first do this with a number 40 drill bit. Eventually these will be opened up to an A4 rivet size. I've drilled all the holes and got the curvature just the way I want it, testing it with a piece of skin. Our next step is to remove the clecos Note that all of the holes fell inside of the bracket area. Now I will go ahead and drill these out to size 30 for A4 rivets, but prior to doing that, we need to put it back on our jig. Now notice I have the bracket support cleco to my template. I'm going to turn this over. Have it clamped to the bottom of the extrusion and the nose touching the edge of the template. And what this allows me to do now is to drill through the holes that we made for that L. And what that will do is drill into our bracket support exactly where it's supposed to go. So I'm going to go ahead and drill these and then open them up to size 30, and then we can remove it and cleco the whole assembly together. I've drilled through. If we look at the other side, what that allows us to do now is then to attach our bent L. And this will be the final assembly. As I will simply remove the template, cleco this all together, and we're going to be all set for riveting. And here it is. I've got it clecoed from the rear. But you got the nose rib, the bracket support, and then the bent L. And we can deburr and apply our corrosion protection and go ahead and rivet this with A4 rivets. And our nose rib is all set to be reinstalled on the spar. Now remember, we have 4 of these to do for each wing: nose rib number 1, number 3, number 4, and number 6. So we want to repeat this whole operation 3 more times for this wing. We need to create a channel positioning template in order to locate the channels on our wings. Now we're going to make this out of plywood. This is 1/2-inch plywood. The thickness is not critical. And if you can read the plans, the dimensions are in there. However, if the explanation I'm about to give you is useful, well then that would be wonderful. If not, just fast forward ahead. Step number 1, cut a piece of plywood 250 millimeters high and 706 millimeters across. Make sure that it is square. From this, we are going to draw some lines because we're going to need to cut the template out of this piece. These dimensions I'm giving you are somewhat critical in order to produce the template that performs its job precisely in locating the channel of our ribs. Now some of these lines I'm drawing are hard to see, so I will describe them. The first line we want to draw is a line that is parallel to the bottom edge all the way across and that line should be 21 millimeters from the edge. 21 millimeters all the way across the bottom. Next, we want to make a mark 67 millimeters up from that line. On the right side, 67 millimeters from that line we just made, measure up and put a point right there. Coming up to the upper left-hand corner, we need to place a mark that is 30 millimeters along the top edge and place a mark. So 30 millimeters from this corner, we want to place a mark. Now we want to draw a line from that point to the point I just described. We want to measure over from the edge 15 millimeters along this line we drew and place a point, and then connect with the line this point up to our other point right here. We want to measure from this point down 44 millimeters and place a mark along that line. Now we want to measure along the bottom edge 400 millimeters and place a mark. From that mark, 400 millimeters from the edge, we want to draw a line that connects up with the point we made 44 millimeters. Now we're almost done at the front. We want to make a line that is 10 millimeters from the edge along the full length. And then at the very top, we want to make a line 20 millimeters down from the top edge and come across here. You can confirm these measurements from the plans, make sure that I am correct, and then I'm going to go over and take it and cut it out. Here's the template cut out. I have rounded off the corners around here. The purpose of this template is going to be to locate the channel. 7V6-2 fits nicely back here. That should fit all the way in there just like that, because this will help us determine how far the channel should be from the front, from the spar, from the front of the wing. So we'll use this, and then also we're going to use this area as a drilling template. We're going to put some holes in here. So some of you may want to reinforce this area with a piece of thick aluminum plate, but that's not required. One of the most important parts of accuracy is the distance from the front, which is going to be placed up against the spar, to where the channel is located. So this distance needs to be pretty precise. Now we're ready to move on to preparing the channels, 7V6-1, and there'll be a bunch of these for each wing. Notice that there is a larger than 90-degree angle on one side and about a 90-degree angle on the top side. The bottom for us will be the wider angle. Now our first task is we need to convert or prepare these pieces come so that they look more like this. Notice that an end has been bent over, and this is going to end up being a mounting tab for one of the ends. Now, the way we prepare this is step number one is we want to draw a line 20 millimeters from the edge all the way around. Remember, the bottom is the angle greater than 90 degrees. And we want to make sure when we draw this line that we use our square to make sure we get a nice straight 90-degree line. Use that on all sides. And then what we're going to do is also draw a line right at the tangent of the bend on both sides, because what we're going to do is remove this piece here and this piece here and bend the remaining piece down and over. So if we draw our lines first, our next step will be to use our snips and cut and remove the area on this side and on this side. And when cutting, cut it twice, right? In other words, cut outside the line and then come back a second time and cut much closer to the line, and you'll get a better cut that way. Don't try and do it all with one single cut. Now, the problem with this is it leaves a very sharp corner where the two lines come together, and we know that sharp inside corners are no good because that can spawn a crack. So what we want to do is use a file and file these two corners so that it looks something like this. And if you'll notice, if you can notice, I've used a circular file and filed the corners away so that it's nice and rounded in there. I use a tool that looks like this. This is just a round file, and by filing in there, I get that nice round circle in there. And that way we don't have a stress point because there are no sharp edges coming together. Our last step then, after we file this away, is to bend this tab upward. Now, we don't just want to use a pair of pliers and grab this tongue and bend it up, because that would leave a very sharp bend. Sharp bends with aluminum, as you can imagine, provide a great place for cracks to begin. We want a nice gradual bend. So instead of taking a pair of pliers and bending this up, we're going to pound this up with a hammer around a rounded edge. Let's take a look. Okay, I've taken it to the edge of my workbench. You can see the rounded corner a little bit better there. I'm going to set it down and then take a small block of wood, and I've run it quickly over my sandpaper just to round the corner off a little bit. Not much, just enough so it's not a sharp, sharp corner. I'm going to put that down and put the edge right where I want the bend to be. I'm going to hold it down, and then I'm going to take a hammer, anything other than a steel hammer, something plastic or wood, something that's not going to mar the aluminum. And I'm going to hold down the block of wood with my hand right here, and then with my other hand just hammer up. And so we're bending around that edge of the wood so that we don't get a real sharp edge here. To be a nice curve radius. Not a big curve, but enough to keep cracking from starting. Because this is a part of your wing, and you don't want any cracking problems on your wing. So avoiding a sharp corner right here is our goal of bending it around the block like that. And here we have the finished product. Notice the relief hole that we filed in with our file, and we have it 90 degrees bent. And that's what we want to do. And we're going to need 4 of these of the 7V6-2, and then we'll make 1 for the 7V6-1. The other end we'll leave just the way it is. We're going to do something different with that. Also, I think it's worth mentioning, before I bent the tab over, I used my file to clean up any teeth mark left by our snips. So we want everything nice and smooth, leading up to the relief holes in the corner. Our next step is to cut some pieces off of 7V6-3. What we are going to do is carefully mark off 40 millimeters, and using our square, make a line and cut so that we end up with these pieces off of the stock, which is 40 millimeters wide. We need a total of 7 of these for each wing. So let's cut these off and then smooth out the edges nice and clean, and we will be prepared for our next step. Our next step is to produce a jig using our workbench and some small wooden blocks. I've screwed these blocks to the top of the workbench, and let me show you what we're going to use them for. We need to take 7V6-2, which we previously created a flange on one end, and be able to place it in our jig for the purpose of attaching a piece at the end. And we need the total length to be exactly 600 millimeters. So what's important here is when you place this block here and screw it to the table, 90 degrees to the table, we want to measure very carefully till we come up with 600 millimeters to this edge over here. And that way, now, and these 2 blocks here are just serving as guides to hold it in place. And now when we attach the end angle to the end of 7V6-2, we can be assured that it is exactly 600 millimeters from each end to the very end. By taking one of the pieces of 7V6-3 that we created, remember these were 40 millimeters long, our goal is to attach them back here. But again, the length is critical, so what we're going to do is simply place it against our block of wood, and that way we can drill it, and each of these pieces will be exactly 600 millimeters long. Now, looking at your plans, we're going to use 3 holes of A4 size, centered and then 12 millimeters from the center. And we'll use those as guides to back drill into our angle piece. So as long as we made our blocks all perpendicular to our table, we know that this will be nice and square. So we'll go ahead and prepare 4 of these per wing. And this is in your plans, but this jig is certainly an easy way to produce those pieces accurately so that our wing will come out very consistent. I'm going to go ahead and drill the 3 holes into the angle. Now for our next procedure, I've moved the block of the jig closer. It is now at 400 millimeters between the 2 ends. The reason for that is we have to prepare 7V6-1, which is similar to 7V6-2, except that it's thicker stock, and shorter in length. So I'm going to place that in place and also cut a piece of 7v6-3 like we did before. And in a similar fashion, we are going to attach this at the end so that we have a span of 400 millimeters and drill through and cleco. Oh, and I should mention that I prepared the end of 7v6-1 in a similar way that I did the channels for 7v6-2, cutting 20 millimeters and bending it over. Exactly the same procedure. I've added a reinforcement to the end of our template. I took a piece of 63 thousandths aluminum, it could be any thickness, and cut it to the shape and riveted it onto the wood. Yes, you can rivet into wood, it holds pretty nice. The purpose of this was so that 3 holes that I drilled, these are spaced 12 millimeters apart, they're in your plans. My wood was kind of soft and brittly, so the purpose of this piece of aluminum plate is just to have a little more accurate and rigid drilling guide, because we're going to use these 3 holes to drill into the ends of our ribs. Now we also want to confirm before we make use of our template that putting up our channel that it fits nice in there, because we're going to use this to position, and just want to make sure that the cut was right so that it fits nicely in there. And notice these 3 holes will be drilling into the flap that we previously made in our channel. I'm going to place this edge up against the back of the spar, and the little tabs will ride above and below the spar caps, but it's most important that we push this as forward as possible against the back of the spar. And I'm first going to use this to align our 3rd rib at station 1480. Template is sandwiched up against the rib with a C-clamp, and it is most important that the template be pushed all the way tight to the back of the spar cap at both the top and bottom. Now you may find that it doesn't like to sit this way because it's lifting the rest of the ribs up, so a small block under some of the other rear ribs will help to keep the stress off. Now, your goal is to align the template at the back so that it is even with the top and bottom surface or flanges of the rib. Now, to confirm its proper location, we are going to take one of our channels and place it, sandwich it in between the 2 pieces. Here's a look from a different angle. And we're simply going to slide the tab in between the template and the rib. I'm going to make sure we push it all the way forward. But once you've confirmed that the top of the flange and the bottom of the flange are even with the rib flange, so that the channel and the rib are all at the correct height, and if you need to adjust the template up or down, you can do that. I would put another clamp on right here and remove the channel, and with the clamp still on, now go and drill these holes. I like to drill these holes with the channel off so I can get the drill in nice and straight and square. As long as you don't move the template, you're okay. And that will leave 3 holes properly located in the rib. And once they're drilled, you can then slide the channel back on. Once again, ensure that it is lined up properly, top and bottom, and then come behind on the other side of the rib where the holes are and simply drill through your 3 holes, and that will drill into your tab there. When you're done drilling, you can remove the template, and that will reveal the 3 holes and also the 3 holes in the flange. And you should be able to re-cleco these together without the template. And find that you have them situated just right. We will skip ahead just a little bit to show why the placement of the rear channel is so critical. The wing is flipped over, the bottom is now up, and if you were to measure from the front of the spar back to the rear of the channel, you would get the measurement, hopefully, of the width of the bottom skin. So this bottom channel has to be positioned just right so that it meets up with the edge of the bottom skin that you're going to put on. And if that channel is too far forward or aft, you will find that the rivet locations for your skin will not fall in the center of the channel, and you're going to have some problems. So if you can verify that before drilling the channel on, that you have it in its proper location by confirming that the width of your bottom skin, which in my case is 705, is where this edge of the channel is located, so that when you do end up drilling the holes for the skin, they land in the center. By making this check now, you can confirm that your rib template is cut to the right size, so the rest of your channels fall exactly into their proper location, both the bottom side and, of course, the top side. And we're back to our angle looking behind the wing. So I've attached the right side to rib number 3. The left side is still loose, not attached. We'll leave that alone. So I will continue with all of my channels using the template to attach the right side of the channel. And what that will end up doing is providing the critical holes in each of the ribs. Then, after we have attached all of the channels on the right side, and we can remove them after we attach them, is then we'll come back and figure out the attachment to the left side. Because somebody's left side is another channel's right side. And it's rib number 4 that we have the short channel. The rest of them are the full 600 millimeter lengths. Other than the shorter length, there is no difference in how we use the template to locate the right side of the channel. As I install each channel, I mark on it its location based on the rib numbers that it joins. I have completed all of the channels and have labeled them appropriately. It is now time to join the left end of each channel. Of course, we have been aligning and joining the right end, and that means we have the left end to join. A couple of steps of preparation before we start with the left side. I have the channel clecoed in place, and then I took a straight edge, and looking straight down, I made a mark to continue the line or the front edge of the channel. This line is going to be used to help us align the channel on the other side. Now likewise, we have to do that with the bottom of the channel. Looking above and over the channel, we see on the bottom flange of the channel, I have clamped a straight edge. You can see it just to the right of the rib. That straight edge is being used to place a mark on the bottom flange of the rib so I know exactly where the flange of the channel ends up, so that when I add the channel to the right of the rib, I know exactly where to place it. And you can just barely see the mark I made. Now we're going to remove the channel on the left and attach the channel on the right using the upper mark and the lower mark as our guide. Now here's the channel between rib number 2 and 3, and keep in mind that we have our bracket clecoed on. Of course, the end of the bracket is undrilled and now fits inside the number 2 rib flanges. And we're going to line it up with the mark we made on the top and down in the bottom. But we're also going to use a piece of extrusion and clamp that underneath to both the rib and the channel to keep them perfectly aligned along the bottom. Have it lined up with the mark along the top. Have a piece of extrusion clamped underneath. I can go ahead and back drill through the 3 holes in the rib, and that will drill into the bracket and ensure that the alignment is proper for the channel to the rib. And now with the extrusions removed, we have it clecoed in place and the channel is aligned very nicely with the rib on both sides. So we want to repeat this for all of the other ribs. The only one we won't do at the moment is rib number 1 because we haven't prepared the channel to the left of rib number 1 yet. Here we have them all clecoed together. Now the very last channel, the one past rib number 6, is a slightly special case. Let's look at fabricating it. We're going to use a piece of 7V6-2, and on the left side we're going to make one of our flanges. However, a little bit differently, we're going to make our mark 20 millimeters in and then a second mark 20 millimeters in, so we got 2 of the marks. We're going to draw along the tangent. So we're going to remove this whole section out, which is 40 millimeters in length. Same with the other side. But we're going to still bend at the 20 millimeter mark. So we'll bend here, but remove all the material from here. Then at the other end, take a look at your plans, but this should be 425 45 millimeters from the bend down there. We'll mark a line and then use our protractor to make a 45-degree mark down. Remember, now this is the top and the bottom. And I just put a dotted line here because that'll help us when we're forming this. We can cut this off first here and then come in with our snips and cut it this way or cut it the other way or any combination thereof. But basically we're going to have a point at the top up here. But do look at your plans to get the proper distance from the furthest point at the top back to the bend. I'll go ahead and fabricate this and we'll take a look at what it looks like. And here's the flange end. Notice also I've made the relief holes here because we have a corner. And at the other end, our angle, 45-degree angle. And we're going to install this down on rib number 6 here. And we'll use the same technique we did before as far as marking our line, top and bottom flange of the rib, and then using an extrusion on the bottom to align it properly. And then drill through the 3 holes. And we're going to let the other end with the 45-degree cut just dangle out there for now. Now we direct our attention to the very root of the wing. Here we have rib number 1, and I've set up the template. We need to prepare the channel for between rib number 1 and the root rib at the very end. We're going to use a piece of 7V1, the thicker channel, and we first need to prepare the end just like we did on all of the other channels, bending it over 90 degrees, making sure we have our relief holes. We need to cut this down, and read your plans for this number, to 295 millimeters from where we bend it to the end and have a straight cut. So 295 is going to be the distance. And then we need to set up our template and attach it properly to the number 1 rib like we did the other ones. Now, one thing we have to be a little bit careful about is the template doesn't have much of the top spar to rest upon, but there is just enough to get a nice fit for that. So I will go ahead and prepare the mounting on rib number 1. Okay, I'm going to remove this now that I have it drilled in the end. And before attaching it to the root rib, we need to grab 7V43. Now this is just a flat piece of aluminum. I believe that's 90 thousandths. And we want to use our plans and lay out a rivet pattern. We're going to drill all of these with number 40 drill just for pilot holes. This doubler will be placed into our channel so that it is flush with the end. And then those holes we drilled will be drilled all the way through into the channel. Now, as you can imagine, right in this area, and I'm not going to drill this hole on the shown on the plans yet, this is where we will attach the rear channel to the fuselage. So that's an important attachment point. So there will be a larger hole that will go there eventually. But basically this will then be attached to the wing right where we originally drilled it. So I'm going to go ahead and prepare this with the holes, and then I will drill it flush with the edge. And again, make sure you view your plans for the dimensional layout of that. One sanity check you should perform is that this line of 3 holes on your doubler plate should be, when placed in its final location, 247 millimeters to the center of rib number 1. So if you were to take a ruler and measure from the center of rib number 1 over to where those 3 holes are located, that line, that should be 247, because that's going to end up being the center of the root rib. And they just want to make sure that the root rib and rib number 1 are 247 millimeters apart, center to center. Now, if you lay out the holes as in the plans, you should find that that measurement comes out just right. But that is one thing you might want to check before actually drilling. This measurement that I'm referring to just now is on your plans. Now we want to cut a piece of 7V6-3 and draw a line down the flange. I also put a little mark at the center. And what we're going to do is place that bracket right along the 3 holes, like that, and then make sure we can see the line through the holes. In other words, that we have it positioned correctly in both directions. And then we'll be ready to mount the channel. Also, I should note that prior to drilling the doubler, make sure it is centered left to right so that it is not sitting in the radius on either edge of the channel. That will ensure that it sits nice and flat, because this is an important part of your wing, and you want a nice tight fit to the channel. And there we have the bracket attached. The attachment for the wing to the fuselage will be a bolt through a hole we'll drill here later. So this side goes against the fuselage, and of course this end attaches to rib number 1. So I'm going to go ahead and attach this, and then the tab that we attached is going to be on the outside of our root rib. Now here's the critical part. The adjustment fore and aft is going to affect the attachment at the fuselage to the wing, with the forward attachment point of the wing, which of course is right there. So what we need to do now is to come up with the precise distance between the forward tab and this mounting position here before we drill and make this permanently attached. So the question becomes, are you building the wing first or the fuselage first? If the fuselage is already built, we need to get a measurement or make a template to transfer that attach distance for the mounting to the wing. If you are building the wing first, then you can set the distance by simply using your template which will set the distance here. Look on your plans to get this perfectly clear on page 7F15. I am going to go make a template from the fuselage because I have completed the fuselage first, and I want to set this precisely so that it will match my fuselage on the right side. Well, our job is to make a template to measure the side of our fuselage. So I'm going to start off with a piece of lumber. I think this is a 1x2, 1x3, and cut one angle to 75 degrees using your protractor. Here's the rear wing mount tab on the right side or passenger side of our fuselage. So what we want to do is take our lumber and place it up against that tab. And we'll get a very nice fit because we cut it to 75. Now we want to go towards the front tab. At the front, and we have a reverse angle here. We're looking at the plane from the pilot side. And by holding our template up against the tab, I'm going to use a pen and mark where the rear tab touches, and that line then will tell me where to cut. We have our wing template in place. Notice that the rear end of the template is sitting on the rear fuselage wing tab, and the front of the template is sitting right behind the dual tabs of the front wing attach. What we need to do, though, to make this template complete is to add the thickness of the front tab metal, because the wing actually goes in between these two tabs. So we need to add the thickness of this metal here, plus we need to add the thickness of the rear tab also, because our wing channel fits behind the tab. So we need to add these two thicknesses to the wing template to come up with the proper exact length. Here is the template, and I've added onto the end a piece of 1/8 aluminum. That is because the rear tab, wing tab on the fuselage is 1/8 inch thickness. So I've added that and just glued it onto the end. And at the front, I looked up on the plans and noticed that the front steel tab is 80 thousandths. Now I've added 90 thousandths aluminum piece of metal there, a little bit thicker, and that's okay. If our template's a little bit larger, that's okay. We just don't want it to be smaller. So I've compensated for the distance required by the mounting tabs on the fuselage, and I can now put this into the wing. And at the rear channel, we have a nice fit. In fact, the channel on the wing will fit behind the tab on the fuselage. And at the front, we find that it fits nicely up to the tab at the front. So it is our job now, with the wing template in place, to go ahead and drill 3 holes in our bracket to attach the root rib onto it while the template is holding the back channel at the proper distance. The tab goes on the outside of the rib, and we can now rest assured that the wing will fit nicely on the fuselage. Keep in mind, if you're going to make an error, make the error towards making the distance between the channel and the front tab of the wing larger. If you go a little bit larger, that just means there'll be a little gap, and we can always shim that on the plane. If you make the channel too close or too narrow to the front of the wing, then there's a chance the wing channel won't fit over the mounting tab on the fuselage, and then you're going to have a problem. So any errors you make towards making it bigger or larger rather than smaller. Your goal is to make a nice fit that fits easily over the tabs in the fuselage. Now we're ready to prepare our Flaperon brackets 7V46. These will require 7 holes. Now we're only going to drill 6 of them presently. Use your plans, and all the holes are located on the plans. The 7th hole, which we won't drill now, is the last one, because that last one position will be determined after we have this set against the rib. But I went ahead and drilled with a pilot hole, size 40, the first 6 holes. I'm going to use this as a template to drill the other Flaperon brackets. There's a total of 4 for each wing, so I'll go use this to drill the holes for the other 3 for this particular wing. And then we'll go place this on the end of the ribs where they are to be located. These will be installed on the ends of ribs number 1, 3, 4, and 6. Just those 4. So don't install them on anything other than 1, 3, 4, and 6. Now I'm going to take the bracket that I've drilled, place it up against the left side of the rib end. And the most important part is that this top be even with the top of the rib, so that when our skin sits on top, it's not being held up by the edge of this. So this top edge needs to be flush with the edge. What I like to do is take a piece of metal, in this case my ruler, my metal ruler, clamp it first of all on top of the rib. That way it will limit the upward position, and then I can slide this up here knowing that it is perfectly aligned along the top. What I can also do is set up a clamp so that I can clamp it in place. So the end is even with the end of the rib, and the top is even with the top. I'm going to go ahead then and drill through on all of my holes and cleco, and then we'll look carefully about locating the last hole. For this last hole, it might be easier to drill from the back side so that you can get it centered in between the tip of the rib, which is very narrow at this point. Now we need to create the rear upper strut fitting 7V44. Now this is the piece that you get. You need to do some drawings on it. Now here's the layout I used to create this piece. All of the vertical lines I drew, I used a square, so be sure to do that. But basically, I started from the left edge and made my first vertical line 16 millimeters from the edge. Then moved over another 74 millimeters and made another vertical line. Then moved over 26 millimeters and just put a little tick mark at the bottom. And then over 15 millimeters and drew another vertical line. On this vertical line, I put a mark 27 millimeters up from the bottom. And that was about it. I can now connect the two marks. I can connect this mark with that mark, and I can connect this mark over to here. Now, I found the center between the top and the bottom, approximately 32 millimeters, so the middle was 16 millimeters. I used my compass and drew a 16 millimeter arc. And that about wraps it up. I will go ahead and cut this out. All of these dimensions are in your plans in one form or another. And here it is all cut out. I went ahead and drilled the hole, just a pilot hole right in the center. Now the next step is we need to mark up the location of the holes for attaching. Now, most of these are in your plans, and the rest can be derived. But for example, the first row is 7 millimeters from the top, and then the next row is 14. Next row is 14. This very first column here starts at 7 from the top, and then is 10.5 and 10.5. So these three are different from the rest of these. And then these should be in a straight line, equal distance from the edge, and then this guy is halfway between these two. The pattern is in your plans, and you should hold this up in place before drilling, just to check out where the holes are going to fit so that it all makes sense. Let's take a look. And here we have the rear upper strut fitting in its location on rib number 4 against the rib and the top. I will clamp a piece of extrusion in place just to make sure the top is even with the top of the channel. And I've confirmed that all of the holes line up nicely into the channel, and I will go ahead and drill with my number 40 drill bit to put the pilot holes into the channel. Now we need to cut a piece of angle 40 millimeters long approximately, and that is going to go right into the corner right here. Now we're going to back drill from the back of the channel through these 3 holes on this side, and over here we have 2 existing holes that we drilled earlier. We're going to back drill through those and then add a third one in the middle, so that there will be a total of 6 holes in this angle. Now, it's easy to drill from behind the channel through the holes that you've already drilled. If you have trouble getting a drill because of the rib that's in the way, keep in mind that a right angle drill makes it very easy to get tight so that you can hit those holes and drill into them very nicely and straight. Our next step is to take a piece of L, regular L angle, about 130 millimeters long, roughly. Length is not super critical. And then we want to close it a little bit more from 90. About that much. Doesn't have to be exact, we can adjust it later, but definitely want to squeeze it its full length. this is going to be placed down here. I've placed two extrusions clamped to the bottom of the channel on either side of the strut fitting. And if we look in the back, you can see I have them attached simply with some clamps. They are going to extend the angle of the bottom flange of the channel. That's the purpose we clamp them on there, so that we can accurately get that proper angle. So our angle will go right there. The purpose of this angle is to provide a surface for the bottom skin of the wing as the skin straddles the strut, because there's going to be a cutout in the skin for the strut, so this will provide a surface for the skin underneath here to be riveted to. So we want this angle to be at the proper height and angle as the bottom of the channel. We will back drill the angle with the bottom row of rivet holes from the back and the hole in our angle over here. And then using the plans, we will cut the angle at the proper distance. And I have it cut to length. And I will have to do some trimming because the upper lip is going to interfere with the upper set of holes in the strut fitting. So I will trim the top of this L to make room for the rivet heads. The L that you placed in the corner, we need to trim this L to the same contour as the long L that we just installed. So I'm going to remove this L and trim this corner off, following this line, which is basically just following the contour of this L here. Now all of these holes will eventually be opened up, accommodate an A5 rivet, so they'll be opened up to a size 20 hole. Now we're going to look at the wing tank channel. Now this is going to go between ribs 1 and 2. One side has a 90-degree bend and the other side has something a little sharper or smaller than 90 degrees. Our first task is to attach an angle at both ends and ensure that the length is 600 millimeters. So the easiest thing to do is to build our table as a jig again, setting up a block on one end and exactly 600 millimeters of block on the other end, and then a edge block 90 degrees so that we can set this right in like that. Then cut two L angles 105 millimeters long, check your plans, and on one of the flanges locate 5 evenly spaced holes. These will eventually be A4. Down the center, use your rivet spacing tool for that. And then place the L angle at the edge of the channel. Then go ahead and drill through your holes into the edge of the channel at both ends, and that will ensure that we have 600 millimeters between each L. Now on the top of the channel where the angle is smaller than 90 degrees, you might want to trim the L at a slight angle so that it doesn't interfere with the top flange of the channel. I did this small trim on both sides on the top. Now we're looking at rib number 1 here, and what we need to do is make a mark 530 millimeters from the very front of the spar cap. So if you take your ruler and attach it to the front of the spar, and following the curvature of the rib, locate a mark 530 millimeters from that front spar cap and place a line. That should be right behind a crimp. We want to do that also to rib number 2 right next door. Now that we have a mark on the top, we also need to find the mark on the bottom flange. This one needs to be 525 millimeters from the bottom spar cap. And that will mark where we're going to locate the bottom of the fuel tank flange channel. And of course we'll do that on rib number 2 also. In fact, if it helps, you can draw a line on rib number 2 from top to bottom, and that will be the front boundary of the tank channel. Now in preparation, I have located 5 pilot holes equally spaced on the outside of the L brackets. And as long as we understand the orientation, the flange that is tighter than 90 degrees is the top, and the rear of the flange, the rear of the channel, is the side with the flange lips. So this would be the front. And we can now go install this between ribs 1 and 2. Notice how I lined up the front edge with the mark that was made. So that's the very front edge. And then for alignment purposes up and down, I have clamped on an extrusion to the lower flange of the rib, and then also that same extrusion is clamped to the lower flange of the channel, so that the lower edge of the channel is in perfect line with the bottom of the rib. I can go ahead then and drill into my pre-drilled holes that I made in the L angle. And of course, I've set up the same thing at the other side. The difference being that we can put the flange inside or underneath the flange of the rib, or you could even cut away the flange for even a better fit, because basically these surfaces are going to be even with each other at the top and the bottom. Your fuel tank sits up front here, so we do want the right dimension here so that the fuel tank will fit just right. Once everything has been deburred and primed for corrosion protection, you can rivet the back channel and associated parts. I started with the Flaperon brackets first. Then I assembled the rear strut fitting onto the channel. And then assembled the doubler onto the very first channel, another area where we use A5 rivets. And then one by one assembled each channel between the ribs and riveted, making careful not to forget the other parts that fit in with the rivets. One area that is not to be riveted yet is the channel for the gas tank. We want to be able to remove that when we fit the gas tank. And I did not rivet the ribs to the front spar. I left those just clecoed at this time because we want to be able to remove the nose ribs and put them back on prior to riveting. You will also notice that I marked every single flange on the top of the ribs and on the rear channels with a center line. We will use this center line when we attach our top skin shortly so that we can easily find the center of those flanges. In preparation for applying the top skin to the wing, I have used a chalk line and made a straight line on the front of my workbench from one end all the way to the other. And the purpose of this line is for being able to align the front spar and keep it straight. Now, you might check your front spar, but mine has a nice wave or bow in it because nothing is holding it in a perfectly straight line. It can be flexed quite easily. So we're going to use the chalk line to keep the spar nice and straight. In fact, after drawing the chalk line, I am going to take this block of wood and align it with the line very carefully and screw it down into the table, because what I'm going to do then is place the spar on this side of the block to keep the spar from being able to move past the line. I'm also going to have one of these blocks down at the other end for the very same purpose, to hold the spar. And then towards the center, I'm going to use a block on the forward side of the spar and push the spar straight to the line. So the purpose of the line and all these blocks is simply to affix the spar on the bottom where it touches the table and keep it perfectly straight. That way, when we put the skin on top of the spar, the skin will align properly with the top edge, and we won't have to fight the skin and the spar to keep them straight. And now our front spar is nice and straight by use of those blocks. We want to leave the back ribs loose so that we can adjust them, because as we look through the holes in the skin, we want to look for that center line by adjusting the ribs left and right. I've also placed a metal 2x4 underneath the rear ribs for the entire length. You can use any suitable material, just to keep the rear ribs off the table at a uniform height, because remember, the rear strut fitting provides a bit of a bump. Now we should talk about this skin. We're looking from the rear of the wing right now. My skin has virtually all of the holes pre-drilled, and the edges have been cut as per the plans. Your wing skin, if it's from an earlier kit, may not have some of these features. For example, earlier kits had holes drilled along the edge, and that would be the rear edge, so don't put the holes at the top of the spar if your wing skin only has holes on one edge. Otherwise, if you have one of the later kits, you'll find it pretty obvious how the skin attaches. For example, we're looking at the very first rib, and that's where the edge lines up. Our goal is to get the front of the skin. In my case, I have pre-drilled holes along the front edge of the skin. We want that front edge lined up with the front of the spar all the way along the full distance, and that will ensure our spar is nice and straight if we let it follow along the edge of the skin. And then you will notice that each of the ribs also has the holes drilled. Even the gas tank channel is drilled. And down here are the holes for the rear channel. Then at the very bottom of the skin is the final set of holes. If your skin does not have all of these holes, then it is a simple matter of you laying out these holes as per the plans. For example, one of your first steps will be to locate the holes for the rear channel. If you don't have those holes, you simply would use a ruler, place the ruler underneath until you get it to the center of the channel, then take that measurement and transfer it to the skin to find the location of that line, and then go ahead and mark that line. And as per your plans, the hole layout is pitch 40, with the additional hole being placed where the rib crosses the channel. The cutout is described in your plans. Notice that to the left of the first rib, this part is going to be open so that we can make our gas tank connections. Our first step then is to ensure that the front edge of the skin is lined up even with the front edge of the spar cap for the entire length. Also, we want to ensure that we can see the line we drew in the center of the hinge flanges through the pre-drilled rib holes. Now, you may not see the line exactly on every single rib, but you want to adjust your ribs from underneath by reaching under and grabbing a rib and moving it back and forth until you can see the rib through the pre-drilled holes. I like to start at the center of the wing, move the rib back and forth until I get it lined up through the holes, and that way, if there's any variation due to the way we built the skeleton, we've kind of averaged out the differences. So in other words, I went to the two center ribs of the wing, adjusted the ribs left and right until I could see the line through the holes, And then check the other ribs to the left and to the right, making sure that that center line was pretty close to the holes in the skin. Once we've got that set that way, so we're comfortable with the skin position, we can then clamp the skin to the spar at either end. And then go ahead and start drilling the holes into the spar cap. I would drill every third hole. I like to start at the center and work towards the ends, so that we have the skin now attached to the spar cap so that it's in the exact position with relation to the rest of the wing, and it will no longer move. And I'm going to drill with my number 40 drill and cleco as I go across about every third or fourth hole initially, again starting from the center of the wing and working to the left and to the right. Now we're looking from the front of the wing. If you don't have the holes pre-drilled, then simply start from a rib. Here's a rib location. And then it will be 40 millimeters from that location in each direction. In fact, you will notice that as you move from one rib to the next, it will be exactly 40 millimeters when it hits the next rib location. Eventually will be A4, so we'll drill them out to size 30 soon. Now we're going to start on the ribs. I'm going to start on the center ribs up near the spar and work every second rivet down, and then spread out to the next rib and the next rib over, same thing, starting at the spar and working the way down, all the way down to the channel. And when we get to the channel, then we'll start at the center and work to the left and to the right from the center. Drilling through the pre-drilled holes with our number 40 drill bit. And this will be your final chance to look through the holes, looking for the line you drew in the center flange and getting a good compromise of adjusting your ribs so that you get the line through the holes as closely as possible on all of your ribs. This wing is really starting to take shape. It's starting to look nice. Now that the ribs have been drilled, I'm now going to concentrate on the rear channel, drilling through the pre-drilled holes, drilling every second or third one, and then going back and filling in the other holes, but clecoing as I go. And I'll do the channel all the way across. Also the fuel tank channel up here, I'm going to go ahead and drill that also. Then, at your convenience, go back and open up all the holes to size 30 for A4 holes, and then put in your copper colored clecos, because all of these rib holes and channel holes and the ones in the spars are going to be taking A4 size rivets. I'm going to defer drilling the holes in the very last channel, the end channel, because I want to level this after we flip the wing over and drill the other side. So I'm not going to drill this section right here. I'm also going to hold off on the very end channel. In other words, defer drilling the holes into that channel. because this is kind of freewheeling at the moment and I want to make sure it's nice and level. So I'll drill this after we flip the wing over. Now we have flipped the wing upside down. Be sure and get a helper to do this. You don't want to try that by yourself. Now, I have rested the wing on top of some steel square tubes. Now, you don't have to use these. The point is we need something to hold the wing off of the table because we have clecos on the skin, so your support needs to be at least 2 inches or about 50 millimeters tall to keep the clecos from touching the table. So about 6 of these or so. The important thing is that they are straight and even. And you can place one roughly under each rib or near to the rib. If you notice, I have lifted the rear of the wing up in order to get the spar 90 degrees to the table. So the back of the wing has come up and I have a support behind it. And my support runs the full length of the wing. Again, some lumber that is straight. I've used a steel 2x4 in my example, which is resting on top of the support and under the wing. And again, the purpose of this is to get the front spar 90 degrees to the table. Our goal is to keep this spar 90 degrees all the way for its entire length. That will ensure that there is no twist in the spar and resulting twist in the wing as we go from one end to the other. So use a level to check the angle of the spar and then keep checking all the way across to the other end of the wing and adjust the back end of the wing up or down to make the spar consistent all the way across. A simple level with a bubble will do it, or if you're into gadgets, you can try one of these electronic levels. It tends to speed things up a little bit. Basically, place the level against the spar, you push a button that calibrates the level to whatever angle this happens to be at right now. And then it remembers that so that you can keep checking as often as you want and get it to the same position that your initial setting was at. Doing it that way, you don't have to be exactly 90 degrees to earth, but it will keep it consistent. Our next step is to add center lines on top of all of the flanges, including the spar. You want to make sure the skin is positioned properly. In other words, that you have it right side up and that you have the front to the back properly and you don't have it flipped around the wrong way. One way to verify is to look through each set of pre-drilled holes for the lines you made on your rib flanges and check every rib station to make sure that line is there. That's one good way to make sure you have it positioned correctly. The front is to be lined up with the edge, the front edge of the spar, and the skin may not go back far enough for that to happen because of our Flaperon brackets being slightly in the way. Those brackets may prevent the skin from sliding back, and what we'll do is make a little mark and a notch to allow them to go back just a little bit further, because our goal is to make sure the front edge of the skin is even with the spar. Another way to get an accurate position from left to right is to look at the holes in the spar and in the skin at a rib station and note that they should line up very precisely. I drew a little line just to show that they do meet at just the right spot. Now, if you notice, my skin at the front has the holes drilled already. Your skin may not have these holes, and that's okay. If you don't have the holes may be in the nose skin, which will fit on top, and then we'll drill through the nose skin and the skin into the spar. And likewise, you may or may not have holes at the rear of the skin. Mine does not, and that's okay. So these variations in the way the holes are set up on your skin will not cause a problem as we're installing it. Also, my skin has the cutouts in the corner already prepared, which is nice. These are documented in the plans if your skin does not have them. Once we have the skin positioned from left to right accurately, our next step is to make a little mark at each location where the Flaperon bracket meets the rear of the skin. What we want to do is make a mark exactly where the skin touches the Flaperon bracket, as we want to file a notch so that the skin can come rearward enough to make sure that the forward edge of the skin is even with the spar. Depending on how you placed your rear channel, you may or may not need this notch, or the depth of the notch will also be determined on the exact location of the channel, whether it was a little too forward or a little too rearward. But at each of the 4 Flaperon stations, make a mark and then make a notch at that mark as needed to pull the skin back so that it is even with the front of the spar. Once we have positioned the skin exactly where we want it, with the front edge even with the front edge of the spar, our next step is to secure it to the spar. However, we don't want to drill through the holes in our skin, because remember, we have a nose skin that will be going on top. So for now, I am going to drill some temporary attachment holes. And if you will notice, this is the location of the spar. I have drilled a hole into the spar in the skin halfway between one of my pre-drilled holes and the hole that lines up with one of the ribs in the spar. In other words, this hole is 20 millimeters from the rib center line, or halfway between where the holes are supposed to go. This hole is going to be used just so that I can cleco the skin to the spar. I'm going to do this at every rib station along the way. Make a hole 20 millimeters away from where the rib center line is and place a cleco. That is going to be the only holes that I drill and cleco into the spar at this time. As I mentioned, we don't want to drill the spar until we're ready for the nose skin. So those few clecos will hold my skin in perfect alignment with the front of the spar. And that's all I will drill into the spar at this time. Once those clecos are in place, I will make one final check with my level to make sure my spar is nice and consistently perpendicular all the way up and down it. And then I need to level and check the rear channel before I go any further. Recall that we lifted the rear of the wing up to keep the spar 90 degrees to the table, and I did that with a support that runs under the full length of the wing. Well, this end piece that attaches to our fuselage also needs to be kept nice and level also. So my first step was leveling the entire rear channel using my level, making sure that was level all the way across in both directions. But in particular at the very end, if you will recall, this was quite wobbly up and down. So you want to support by using your level and making sure that this last channel section is nice and level and in line with the rest of the wing by building a support and getting this nice and solid. Because we're going to be drilling into this, we don't want this wobbling down and up because it's critical to keep this all straight. So use some additional support underneath to hold this level. And that is going to be true at the other end of the wing, at the wing tip where we have the last piece. So once you are sure that the entire channel is nice and level all the way across, we can then begin drilling the skin to the ribs. Just like we did the top skin, we're going to start at the front of the rib, not into the spar. We're not going to make any drilling into the spar as we mentioned, but the next holes that go into the rib, use our pre-drilled holes and drill them every third hole and cleco them going towards the back. And then we'll move to the next rib over, starting towards the spar, going back, and then the other side. I'm going to use my number 40 drill bit and cleco as we go. We will not, however, drill into the rear channel at this time. We will stop our drilling when we get to the last hole before reaching the channel. All the ribs have been drilled, starting with number 40 and then opened up to number 30 and clecoed. We can now focus on the area at the rear channel to the very edge of the wing. You probably have noticed by now that the location of the rear channel with respect to the back edge of the bottom skin is important. In fact, mine is maybe out just about 1 millimeter too far. It's not too bad. But you can see, especially if you're watching this video in advance of building the plane, how important it is using that template to position the rear channel, because if this channel is too far forward or too far back, it's going to cause a problem in our edge distance when we go put on our next piece, 77-4, because it's going to overlap right on the channel. Now we can discuss preparing 77-4, which is the very rear part. Now, there are two pieces like this. One is longer than the other. We want the inboard, which is 77-4, and it's 1940 millimeters in length. So you don't want to pick up the shorter one. It won't work. Now, there is a flange or slight bend, that goes towards the back of the wing, and the flange should bend up, assuming your wing is upside down. It will ultimately line up with the end of the wing, the inboard end, and then the other end of it is going to go up to the strut fitting. And we need to prepare this end so that it will fit. This is in your plans, but here's a summary of the cutout you need to make. Here I've pulled the left edge towards the camera here so we can see it a little better. This will be right in the middle of the wing against the Flaperon bracket next to the strut fitting. The cut we need to make can be summarized as follows. Align 25 millimeters in and 22 millimeters from the top, going over 125 millimeters and 125 millimeters. We're basically going to cut this section out. Now, we do need to make sure we use a drill bit and round the corners, right? These are inside edges here and up here. So we'll use maybe a 1/4-inch drill bit to make a nice round corner so that we don't have a sharp corner. And we can file this sharp point a little bit and make that rounded. And we'll do that and take a look at how that fits up against the strut fitting area. Pull this into place like that. So this edge goes up against the strut fitting and this edge against the Flaperon bracket. Now we may need to trim this edge, possibly, maybe not, because ultimately our goal is to get the edges of the top skin and this to match up, but don't worry about that quite yet. We have one additional problem. You will notice that the piece won't sit flat, and that's because right behind is our Flaperon bracket. And what we're going to need to do is create a notch in our piece here to accommodate this bracket. Make a mark. So that we can draw the line for this bracket and cut it out. Let's take a look at how to do that. And of course, before we do that, there is a second bracket located at rib number 1, where we also have to make a mark and make a slot. Here's one technique for making the slot. Now, my original mark was right in between these two lines. I used my square and measured down using the plans, 125 millimeters, and drilled a number 30 size hole. You could also drill a number 20. And then carefully drew 2 lines that bracket the hole. And this will be the slot. Here's the flange end down at the bottom. Now I'm going to use my metal shears, the ones that look like the scissors, because these don't really leave serrations or bend the metal much. I would not use my green or red whisk snips for something like this, but with these shears I can, if I'm careful, accurately cut these lines very quickly and leave a nice smooth edge at the same time. It's important to do one slot at a time. Don't mark both slots because you may find that if they're off a little bit, they're not going to fit. And these slots, for the most part, are going to be all covered up with an L bracket anyway, so don't worry about making them too wide if you have to. They will not be showing. And that took me all of 20 seconds to make 2 cuts, and that's nice and straight all the way down to the hole. And I can enlarge and clean up this hole. In fact, should really use a number 20 drill bit for that. Let's see how this fits. And that's just what the doctor ordered. Fits very nice. And again, this slot is not going to show because we're going to end up putting two L brackets on either side. So if you need to make the slot wider, not so much for your first cut, but for your second cut, because now your second cut should be checked and marked, should be marked and then cut, because this first slot obviously holds the piece rigid. So go back now and mark your next slot, double check that it's okay, and cut it the same way. And here's a look at the finished product. Right now we have the piece laying on top of the wing. It will slip underneath the skin when we go to rivet it on. And at the very end, we do need to make a cutout, and this is so we can gain access to the wing attach bolts. And some final trimming can be done later at the very tip after the wing is all assembled. But I will cut out this part, ensuring that the radius is made in that corner. Then we will proceed to making our trailing edge at the outboard end of the wing. 7V75, the left trailing edge, is a lot easier to fabricate. We're basically going to slide it all the way to the Flaperon bracket as far as it will go. And then we only have one slot to cut out. We'll mark it right at the bracket and cut it out, and we're basically done. Very minor trimming at the very edge, at the very wing tip, and we will do that later. So I'm going to go ahead and cut out the slot and be done with the left trailing edge. At rib number 4, we are not going to drill holes. In fact, they are missing from the skin at the forward half of the wing on the bottom here. And that's because we have some additional hardware that will be mounted here later. So no holes to drill, we'll do that part later. Also, at rib number 2, we find that the two last holes are also missing. We should also avoid drilling these two locations until later because of additional hardware that goes on there. In preparation for drilling the trailing edge, notice that I have slipped it underneath the bottom skin all the way across. We are going to mark a line on the trailing edge of the bottom skin where we will mark exactly where the rivets are going to go. The rivets will go through the bottom skin, the trailing edge skin, and then what's underneath that, of course, is the rear channel. So the line we make for the rivets should adhere to our edge distance minimum of 10 millimeters. You know where your channel is underneath. So measuring up 10 millimeters from the bottom edge of the skin should put us in the proper location to get the channel underneath and maintain the edge distance through all three components. So my first job is to draw a line all the way across the wing, bottom skin, and then we'll come back and actually mark where the rivets are to be located. And here is my line. drawn all the way across. At rib number 5 and rib number 2, I have drawn a line down the center of the rib line and crossed my line. I did that at rib 5 and rib 2. The reason is that our goal is to space every rivet along this line at 40 millimeters. So I got my rivet fan set up precisely at 40 millimeters, and this will allow me to mark the locations of all the rivets going across. Now we have a few exceptions which we need to talk about. While every rivet is spaced at 40 millimeters along this line, we do not want to drill if we're within 15 millimeters of the Flaperon brackets. In other words, I don't want to drill this one right here, because on each side of each Flaperon bracket we're going to have another piece of hardware, an L angle, and that will have its own rivet and its own rivet location. So we want to make sure we do not place any rivet lines anywhere within about 15 millimeters of both sides of each Flaperon bracket. Other than that, 40 millimeters is the spacing along this line. And what's nice is that our rib center lines are on multiples of 40 millimeters. So you will find that a great reference point each time is at the rib center line as far as where to start to position coming up with the 40 millimeters along that line. Here are my rivet markings, every 40 millimeters along the line. And notice when we come up to a Flaperon bracket, I don't let any of the rivets get within 15 millimeters of each side. Moving along the wing. Notice that these two I've circled red because those are not to be drilled. There were no holes in the skin because we have a bracket that goes there later, so do not drill those. Those are at rib number 2, of course. And then when we come up to a Flaperon bracket, again, no rivets on each side. Another place I've circled 2 locations is right behind the strut pickup for the rear channel. I've circled those 2 because you may not be able to get your rivet gun in there. So don't drill those now. You can get your drill in there, but if you can't get your rivet gun in there, it won't do any good. What we'll probably do is move each of them, one to the left and one to the right a bit, so that we can get our rivet nose in there to pull the rivets. And all the way to the wing tip, the very last one, I am not going to rivet now. Take care of that when we build the tip. So these, I will start with a size 40 drill bit and then open up to size 30 and cleco every second or third hole. Now it's important before drilling to make sure we have the very edge lined up perfectly with the top skin, and that we use clamps to ensure that it does not move while we're drilling. Also, make sure your wing is nice and level. Check with your level again, because once you start drilling, that will cause the wing to become fixed in its position, and we don't want to fix in any twists that shouldn't be there. Also, remember at the end, both the inboard and the tip, we want to make very sure that that last section of channel, of rear channel, has been blocked up so it's perfectly level with the rest of the wing. As once we drill, it will hold it steady and will not be movable after that point.